Hello and welcome to this SSE Symposium, Anomalies in Modern Astronomy Research. My name is Annalisa Ventola. I am the Chief Editor of Edge Science, and I will be one of your hosts for this event. With me, I have Dr. Beatriz Villarroel. She is the Program Chair of the Symposium, also the Project Leader of the Vanishing and Appearing Sources During Century of Observations, the VASCO project, where she is searching for vanishing stars and other anomalies in the sky. She received her PhD in astronomy from Uppsala University in 2017. She is currently an international postdoctoral researcher, sharing her time between the Nordisk Institut, or NORDITA, and the Instituto de Astrofísica in the Canary Islands. In March of 2021, she received the L'Oreal UNESCO Award for Women in Science, a prize in Sweden for her research on vanishing stars. And I will let Beatrice introduce what we are going to be experiencing today.
Hello, welcome everyone. It's a great pleasure to host this symposium. So I'm going to explain to you why I think that anomalies are so fascinating for astronomy. So to start with, now I'm going to click here, does it work? Yes. The history of astronomy is full of interesting anomalies, and these anomalies have been progressing our knowledge historically. Here's a few examples. For example, quasars, when they first were discovered, and the discoverer, Martin Schmidt in 1963, he saw a star, and he saw something that, well, looked like a star on the sky, and but he was very surprised by that. He saw that the spectrum of this star wasn't the one that you could expect. Instead, he saw something that looked like the spectrum of a galaxy, and that it was redshifted and very far away outside our own galaxy, which of course was a very puzzling discovery. And today we know that quasars are these supermassive black holes that are creating lots of gas and are emitting a lot of light, and they emit so much light that they sometimes look like stars. But that he didn't know in 1963. And this is an example of an anomaly that got resolved, and today we know what quasars are, or we actually don't know so much about quasars as we should know, but it was an anomaly, and today we know that this is a natural astrophysical object that we all want to understand. They have not always you're going to resolve a problem over time. For example, there was the example of anomalous redshifts, where Halton Arp, an astronomer in the United States, saw how two galaxies were connected. He thought that they were exchanging gas. However, their redshift was, which is indicating the distance, was totally different. And this didn't fit at all with the idea of cosmology, and that redshift can be used to measure the distance to the object. Here you can see an image taken by actually one of our participants of this symposium. You can ask him about that later. But this was an anomaly that people argued a lot about for 20 years. And for 20 years, maybe these discussions whether this is a real thing or not went on until people got simply tired of it without actually resolving whether this is something to be concerned about or not. Most likely it isn't something to be concerned about, because we can have overlapping things that look like they are connected while they are just foreground objects. So when the pulsars were discovered, and people saw, or Jocelyn Bell, who discovered it, she saw some very fascinating signals in her new images from the new radio telescope. And here, the first idea was maybe that is little green men. However, we know today that pulsars are very natural astrophysical objects, even if it, of course, also looked like an anomaly in the beginning. Another example of anomaly that is more recent are fast radio bursts. And this is something many astronomers work with today, and they try to understand the physics of what is actually driving these fast radio bursts. It can also get even more exciting, like with the Tabby Star, which is a star that was fading a little bit over many years, and people were trying to understand like what is causing this loss of brightness. And one idea that came up is that it could have been an alien megastructure, and this was discussed during 1 year or two. However, again, we today know that this is most likely a very natural object. But these anomalies have something in common. They excite scientists because we want to understand them. We want to understand what is actually driving this anomaly. Why is this anomaly interesting? And by studying these particular objects, we can learn a lot about the universe, and maybe we can discover something more. Like, for example, many of us want to discover ET, or extraterrestrial intelligence. And when we look for these anomalies, it is one of the possible outcomes. I think we're going to hear more today about OMMUA from our next speaker. So I will not tell too much about that, but that is one of the most fascinating anomalies we have today, and also a very interesting topic to listen about. So I hope you're staying for the first talk. And if you want to read a little bit about how anomalies have been important in astronomy, I suggest that you read this review by myself and Dr. Geoffrey Marcy that was published half a year ago. And so I leave you with 5 outstanding speakers, and well, let it begin.